Welcome back. This is question 4B from the practice exam, and we'll start with part A of that question. This question talks about the decomposition of magnesium carbonate to magnesium oxide and CO2, and you want to find the delta G of the reaction at 298 and at 1200 Kelvin. So remember, your equation for delta G naught is related to the enthalpy change minus T delta S, the entropy change. Now these values here can be found, if you look back in your data section, we can calculate those using delta H naught F values and absolute entropy values. So if you remember your equations for these, so to find delta H naught of a reaction, you're using the sum of the enthalpy of formation values for the products minus the sum the enthalpy of formation values for the reactants. This is a variation on Hess's law, or works on Hess's law. So in this case, I'll write them out. And in this case, also, you have to watch out to make sure you don't have any stoichiometric coefficients, or if you do, you have to incorporate those in this equation down here. This is a balanced chemical equation already, and it just happens that everything is already one-to-one. It makes it a bit easier. So first of all, we would have delta H naught F of CO2 plus delta H naught F of magnesium oxide minus delta H naught F of the magnesium carbonate. If you input all of those values to the math, you should end up with a value of 117.3 kilojoules per mole. Now you do the similar equation for the entropy of the reaction, and doing that, this time you're using absolute entropy values, but you should end up with a number 174.74. This is joules per mole Kelvin. So keep that in mind. This one's always in joules, and this one's in kilojoules, generally speaking. But now you're ready to go ahead and do delta G using this equation up here. So if we're going to do delta G at 298, you're just going to be subbing in 298 here. Remember, this is kilojoules and joules, so you have to either turn this into joules or that into kilojoules. Either way, if you do that for this one here, you're going to end up with a value of 65.2 kilojoules per mole. And at 1200 Kelvin, this value becomes minus 92.4 kilojoules per mole. So we end up going from a non-spontaneous reaction to a spontaneous reaction.